Hello, my calculus doing friends. I've been very bad at giving you the code words this week. So Monday I emailed you that it was hope. And Tuesday I didn't tell you what it was. I forgot. It's going to be peace, P-E-A-C-E. And then Wednesday, my friends in Zooming with me helped me choose banana for Wednesday. And for Thursday, we're having mango as our code words. Today we're looking at 4.4, the indefinite integral and the net change theorem. And so I don't know if you remember when you were finding antiderivatives in 3.9, but the notation is a little bit awkward, I thought anyway, and now they're going to give you some nice notation for finding the antiderivative, and this new notation comes from the fundamental theorem of calculus. So this is, indefinite integral, and I lost an E right there on my indefinite integral, the antiderivative. So this is the integral sign, which is a big S, which stands for sum up, like add up. So it's a big S is what it looks like, the integral sign. So the integral of f of x dx asks us to find the antiderivative. And so that means that if I took the derivative, I would get back to what I started with. And then there's a basic table they give you in your textbook of antiderivatives. And I'm going to add a few to this that you can have, I think is a good idea to have anyway. Oops, I have too many things and things are in the way, but this table came from your book. And so that if you have the integral of a constant times your function, you can pull the constant out in front and then take the antiderivative. If you have the antiderivative of a sum, you could break it apart and find the antiderivative of the pieces. If you have the antiderivative of a constant, dx, then that's going to be kx plus c. If you have the antiderivative of x to the n, you have the integral of x to the n dx, that's going to be the unpower rule, as I call it, x to the n plus 1 over n plus 1 plus c, where n is not equal to negative 1. If n is equal to negative 1, then you've woke up and you're in Calc 2, and this, and hopefully you won't still be at home in Calc 2. The integral of sine of x dx is equal to negative cosine of x plus c. And there's another way that you can write this, and I think it's really good. And that is this. I'm going to add this to it right here as neatly as I can. The integral of sine of ax, where a is a constant, dx, is equal to negative of cosine of ax divided by a plus c. Now I can verify that that's true when I put that constant a there times x by taking the derivative of this and showing you that it's equal to that. The last book we used, they had them, instead of listed like this, they had it listed like that. And I think it's really, really helpful because it keeps you from having to use a U substitution, which we're going to learn in 4.5 in order to find this. And they actually threw some of those in this section. So anyway, so the integral of cosine x dx is equal to sine of x plus c. And so this I'm going to add, this is the cosine of a of x dx equals sine of a of x divided by a. And you could do that for all of your trig. So the secant a of x, and you could do that for this one too. So just imagine you would put a of x, and then it would be negative cotangent a of x divided by a. And same here. Now, these would have to be the same input. They couldn't be, this one be 2x and that be 3x. They have to be the same input. So if they are the same input, so the integral of the secant of a of x times the tangent of a of x dx, then the antiderivative there is the secant of a of x over a plus c. So they do have to be the same, and so in same character. Okay, so they asked me here to find the general indefinite integral. So it's an indefinite integral. It doesn't have bounds. And the answer here is going to be a function. It's not going to be it's not representing without the bounds area under the curve. And so it's basically saying find the antiderivative. And I can't find the antiderivative of a product. So you notice that none of these here are saying what to do if you just had two things being multiplied together, except for that one, huh? Well, and that one, but not two things like this. So what you have to do is multiply it together first. So when I do, remember the power rule from algebra, this is t to the half, and you would add it with the 2. So half plus 2 is 2.5. So this is t to the 5 halves, if that's 2.5, plus 3t to the 1.5, so that's 3 halves, plus 2 t to the half dt. And people always ask me, what does the dt stand for? And remember, this came from that notation. Remember that they gave us the sum of f of xi, so that's all these, and then it was delta x. And to me, I think that they were trying, this is the sum sign, that's the sum sign. They were trying to make the notation kind of similar, and this is the height of the rectangle times the width, and so I just think that that's where this dt came from, that notation. Well, later when you go on in math, that dt is going to keep you going on what variable that you kind of have going, because you're going to have more than one variable running around. So it's going to be really, really helpful. So to me, this says find the integral with respect to t. Find the antiderivative. That's a whole piece to me. So remember, I can use the power rule. So you add 1, so when I add 1 to 5 halves, I get 7 halves, and you divide by the same darn thing. So that's dividing by 7 halves is the same as multiplying by 2/7, plus the 3 just holds still, times add 1, so that's 5 halves, and divide by the same darn things, multiply by the reciprocal, so times 2/5, plus the 2 just holds still, add 1, so 3.5, and divide by the same darn thing, so multiply by 2/3, and then plus a constant, because I want the general antiderivative, right, the general indefinite integral. And then all I have to do is make this look just a tiny bit nicer. So 2/7 t to the 7 halves, plus 6/5 t to the 5 halves, plus 4/3 t to the 3 halves, plus c. And there we did that one. And we did a lovely job at it. Okay, so we're going to try another one here. My mom says that she's so bored that she's going to watch my videos. So a big shout out to my mama watching this video. And so this is problem 16 out of your book, and it's asking us to find the general antiderivative, or the general indefinite integral. So the antiderivative is what we're trying to find. And you notice that that's not in my list to do a division. So here's my list again, right? And I don't have a division in my list. So what I have to do is I have to divide this first. So that's what I'm going to need to do, is divide that. And at the bottom of the page, this one is light trig substitution is what I call it. And you'll know what light trig substitution is when you get to Math6B and you see some pretty hard trig substitution. And so what I'd like to do is I'd like to use trig substitution so that I could divide it. Sine of 2x is equal to 2 sine of x cosine of x. So here on number 16, this is going to be the integral of 2 sine of x cosine of x divided by sine of x dx. And then that's the integral of 2 cosine of x dx, because the sines can drop out. And then, well, I can find the integral of 2 cosine of x. The 2 holds still. And then I take the antiderivative of cosine, and the antiderivative of cosine is sine. So this is sine, and then plus c. So there's our answer there. Notice I don't find the antiderivative symbol after I find the antiderivative. So I don't write the integral symbol after I find that integral. Then this is problem 2 in your textbook. It's asking us to find the integral of cosine squared x dx, and you notice that if you look at your list, that's not one of them that I know, right? I know for cosecant squared, and I know for secant squared, but not for cosine squared x. And so that's where trig comes in, trig substitution, because I want to make it look like something that I do know. And so that's what I'm going to try to do. And so down here are some trig substitutions that you might need in order to find antiderivatives. And so here is cosine squared x equals 1/2 times 1 plus cosine 2x. And so we're going to make that substitution. And then that half is multiplied there, can go out in front. And then I know the antiderivative of a constant, 1, right? That was one of my properties that I do know, is I know the antiderivative of a constant. It's equal to the constant times x plus c if you have dx. And then the other thing I have here is cosine 2x. And so that's where I want to use this. Cosine of ax dx is equal to sine of ax over a. In my case, I have 2. So I'm going to take the antiderivative here of these pieces. I need parentheses because it's a binomial. So the antiderivative of 1 is x, 1x, which is just x, plus, and then the antiderivative of cosine 2x is sine of 2x divided by 2, and then plus c. And it really doesn't matter if some people put a plus c with the x and a plus c with this, and then they add those two constants together and you don't know what they are and say that's a new constant. And you don't have to do that. That's a constant. And then I'm all done. I could leave it like that, or I can multiply it together, my choice. So I can write this as 1/2 x plus sine of 2x over 4 plus c. That's a good answer. This is a good answer. It's probably okay to get a common denominator between the 2 and the 4, and that would be a good answer too. So all of it, it's all good. And so there we have that. Okay, so those were got a little bit tricky there. And then he throws in some integrals that have bounds. So those represent area under the curve. And so I'm looking at this one. Looks really complicated. It doesn't matter if this is d theta or if that is x, and then everything would be x. It would be exactly the same. So it's like a dummy variable. And so if it bothered you, you could write it as x, and that would be great. And so what I need to do is I need to find the antiderivative, and then I need to evaluate at the top bound minus the bottom bound. And so the problem is that this is tricky to find the antiderivative on. And so does anyone have any ideas at what I could do? So there's different ways that you could approach it and give a try to it. And whatever you decide to do, if it doesn't work out, you just erase and you try something different. And so if we were in class, people would be telling me different things. So some people would tell me divide the pieces is what some people might be telling me. And you could give a try to that and see if that leads you to being an integral that you know over here, right? And with your trig here. that you might use on the other page. And so, and other people are telling me, hey, factor out a sine and see what you get. And all of that is good. And so whichever one you think to do. I don't remember which one leads the answer, but I remember that there's two ways of going and they both seem the natural thing to do, and one of them leads to the answer and the other doesn't, and I don't remember which one's which. So I get to decide, and if I guess right, then I'll be sad because I would rather guess wrong so that we would have to start again. And so I know that sounds crazy to you, and sometimes no matter which way you go, you'll end up there. So I'm going to try the dividing the pieces. So secant is cosine, right? 1 over cosine. And so this is, I have, if I converted this into cosines, this would be 1 over cosine. And then do you agree that this would become the sine of theta multiplied by cosine squared theta? If I just turn that into, so that's not something I'm going to be able to find the antiderivative of, so I feel kind of stuck there. And so, so that wasn't a helpful thing to do. Can you think of anything I could do? So I'm remembering the things that I can find the antiderivative of. And so, and of course that's not on my list. So I'm seeming kind of stuck. Do you guys agree with me? Now I could then write the cosine squared there using that property, this property here. But then I think I'm going to end up with sine times that stuff, and that seems kind of scary. It's still a multiplication and of things, and so I think I'm going to I feel pretty stuck there. I was kind of hoping that somehow I would be able to convert this maybe into like secant x tangent x. And that would be nice if I could do that, because I know the antiderivative of that. And so I'm just kind of looking at the ones that are a little bit, have a product. Secant x cotangent x. That's the other one, right? And so can you guys, would that work here, that I can convert this? Well, if I rearrange this so that this was 1 over secant squared, 1 over secant theta times sine of theta over secant theta. No, that's not going to work, right? That's not, okay. So maybe my other way of factoring out the sine, maybe that will be better. So let's go try that. So that didn't yield me, I got stuck, right? And I told you I was trying to pick the one that would get me stuck first, and I got lucky and did. So now I'm going to factor it, I think, anyway. I'm going to factor out a sine and see what you guys think. So I get 1 plus tangent squared theta over secant squared theta, d theta. And of course I have all my trig stuff with me that I can use. And so I notice, ooh, 1 plus tangent squared x is equal to secant squared x. And that would be quite friendly, right? Because here I have that. I know I have it with theta instead of x. So this would be the integral of 0 of pi over 3 of sine of theta. And then this would be secant squared theta over secant squared theta. And the secants drop out, hot diggity dog. And then that's the integral of sine d theta. And the integral of sine is negative cosine theta. And I'm going to evaluate that from 0 to pi over 3. Notice that I took the antiderivative, so I stopped writing the antiderivative sign, the integral sign. So I hadn't taken the integral, so I was continuing to write it as I simplified, telling people that I know that I haven't found the integral yet, and now I have found the integral. And I'm going to evaluate this, and we're going to see how we do. So this is negative cosine of pi over 3. So it's my up bound minus my low bound. Right, so here's my low bound, negative cosine of 0. I usually put parentheses around both of them. And then now all I have to know is the cosine of 0 and the cosine of pi over 3. And then I'm in business. And so, and you can look on your calculator for them just to verify, to make sure. I was thinking that it was half, but then I thought, oh my gosh, what if I'm wrong? Could be bad. So this is negative half. This is an add. And then the cosine of 0 is 1. And so when all this work is done, I get half. And remember that this was going to find me the area under the curve. So I asked Desmos to graph y equals that mess right there. And that's what it looked like. I know what you're thinking. Is it just the sine? Y equals the sine? Y equals the sine of theta? Yes, that's what it is, right? Because when we simplified it, that's what it was equal to. And they said that the area under the curve, so this area under the curve is equal to half, is what they're saying. And so if you kind of look at, well, this is, here goes 1, right? And that's probably the square root of 2. 1 somewhere, not exactly that. Anyway, so this is, oh, pi over 3 is where I'm going. Pi over 3 is just a little bit further than 1, right? Just there, that much, because pi is 3. And so that's that area, and I'm saying it's about half. And if you kind of look at the rectangle, the square I got there, that's a 1 by 1 square. Hey, it's pretty close. Okay, so now we're going to try 40 and see how we do. And they have the absolute value in there, and none of my stories over here, none of the things that I know the antiderivative of have absolute value in it. So that means that if I'm going to use algebra means of doing it, I'm going to have to get rid of the absolute value. So how you get rid of the absolute value is by using the definition of the absolute value. And this is going to get messy. So take a deep breath, maybe pause, and get some happy thoughts going. Because if you use algebra to do this, it's going to get messy. So the absolute value of 2x minus 1 is equal to 2x minus 1. And this is, and I'm going to write that over here, this is if 2x minus 1 is greater than or equal to 0, right? So if I add 1, 2x is greater than 1, and divide by 2, x is greater than or equal to half. And so this is if x is greater than or equal to half. And then this is equal to negative of 2x minus 1 if x is less than half. So those are my conditions kind of running together there. So I come back over here and I look. And 0 to 2, half is in that interval. So I'm going to have to break this into 2 pieces at 1/2 is where I'm going to have to do it. So I'm going to have an integral that goes from 0 to half of my function plus, and then an integral that goes from half to 2, so that I go all the way from 0 to 2 of my function. And so when I'm between 0 and half, then my values are smaller than half. So I should be using negative of 2x minus 1. So negative of 2x minus 1 dx. And you can take and pull that negative out to the front if you like. That would be just lovely. And then let me just set this other part up, and then we'll find the pieces. So going from half to 2, so that's bigger than, x is bigger than half, so I would use 2x minus 1. And so now I'm just solving both of these pieces. And so this is a negative of the integral 0 to half of 2x minus 1 dx, right? And if I take the antiderivative of that, so my negative is going to go here with parentheses, then that would be 2x to the second divided by 2. So do you guys agree that 2 divided by 2 is 1? And so I'm just going to have x to the second here. And the antiderivative of 1 is negative x. And I don't have to put plus c because I have bounds, right? And so, and I'm going to evaluate this from 0 to half. And then I'm going to add that with whatever I get here, which I didn't have to break it into a piece. So this is x squared minus x from half to 2. So my up bound minus my my low bound, and I could get kind of messed up if I'm not careful with that negative that I have there, and so I do have to kind of be careful. So it's going to be this one minus that, right? And so when I put in half, I'm going to get half squared is 1/4 minus a half. And I can do that on my calculator, and then it's going to be negative of that. So I'm putting in the up bound, I'm putting in half. And so I'm squaring that, and I'm taking away half. And I got negative 1/4, and then a negative times a negative 1/4 is a positive 1/4. And then fortunately here I get 0. And then I'm going to add that with, and then what I'm going to get over there, I'm going to get the up bound minus the low bound. Right, and because it's add, I don't have to be that careful of what's going on. So I'm going to have here 2 squared is 4, minus 2 is 2, and then I'm going to have half, and I think when I put in half, I already did that, and I got negative 1/4, so I'll put that negative 1/4 here. So when the dust clears here, I'm going to get 1/4 minus 0 plus 2, plus, because I have a double negative, subtract of a negative, so plus 0.25. And so I got 5 halves. 2.5, right, is what that integral is equal to. Now, there's another way that they showed us to do this integral. So that was using the definition, and I put a note down here. Sometimes it's easier to use geometry. And this one is certainly one that I could draw, and that it has straight lines, so it would only be finding the area of triangles. And so not all of them can you draw and then find the area of it. But if I was to draw y equals 2x minus 1, right, I want to draw that. And so I know that it's going to have a turning point at half. And so I'm going to put that on here. So here's half, and it's at 0. So if I was to pick half and put it in there, then my output would be 0. And I know that I'm interested in it going to 0. And so at 0, it's at -1, but it's absolute value, so it's at 1. So here it's at 1. So this is half, so this is 1. And so this is how it looks. And then it goes over here to 2. So this is 1, and then here's 2. And at 2, if you put in 2, you get 4, take away 1 is 3. The absolute value of 3 is 3. And you know me, I'm going to draw this right to scale. It's going to be looking so pretty that people will want to make a print of it and put it on their refrigerator. Okay, so now I'm trying to find the area under the curve that's trapped by the curve, which I know is a straight line. That's down there at 2. And so I can find the area of those two triangles. So I have half, and then the base of this triangle is half, times 1, so base times height, right? Half base times height, and so this is the base, and that's the height, right? And so this is 1/4 plus, and then here for this triangle, it's 1/2, and then the base here is 1.5, and the height is 3. So when you do that, you get 9/4, and you add those together, you get 10/4, and then you reduce it, and you get 5/2. So there, I've done that problem two ways. One way using algebra and the definition of absolute value, and the other way using geometry. Now, I wouldn't be able to do it on anything that wasn't straight lines, so that I could have triangles and, you know, and whatnot, but this one is one that I could use geometry on. And they had these in the section of geometry, and then they threw some in here as well. And then I think that I'm going to call this video right here, and then make another video, because I'm going to go into 2 videos. This one's so long. And so I'm going to have 4.4 part 2.